Hello. Today I'm going to show you how to configure internet access through a Cisco ASA 5505 firewall. Here I have already drawn out topology in Packet Tracer. Here on top we have a server which is on the outside and the public side. It has a web server configured on it, which answers to the name hooligan.com and www.hooligan.com. The IP address is 1.1.1.2, and the DNS server is also located on the same machine. So we'll just have a quick check to see if that configuration works first of all. So we start off here. Ping 1.1.1.2, which is the IP address of it, answers like that. And we try the names as well. Ping hooligan.com, see if that works, which it seems to do. That's just great. Ping www. Okay, I'm misspelling all the time. Hooligan.com. See if that one works. It does. So that server seems to be already configured. So the server and the public network is already configured. And we see, does it have the IP address for the default gateway? Yes, it has. So that address then we will have to assign to this interface here. This interface will be 1.1.1.1 because it's the default gateway for that one. Out here it should be really ISP router or something, but I made simplified things a little bit just because of the thing that I really want to show you in this exercise. So that was the public side, or the outside as Cisco wants to call it. We have a look at the inside, or the private network. See if we have any IP addresses there. If we press on DHCP, what happens? Yeah, it gets a configuration. But one little thing is missing, DNS server. That's not good. We have to do something about that. Look at the other PC. We have to enable DHCP on that one as well. And sure thing, you see the same thing is happening there. So the question is, where does this IP configuration come from? Well, of course, it comes from a DHCP server, which is, the same ASA here, the one that we're going to use as a firewall. Let's click on that one. We go to command line. This is what it looks like first time when you come into an ASA. Enable, of course. There's no password set. Conf T. What I have to do now then is to have a look at what does that DHCP configuration look like. So we go out. Yeah, I can do like this. Do show run. No, you cannot do that. That's what you can do on switches and routers, but not on a firewall. So I have to go to exit, and then we take show run here. Here you see that VLAN 2 has no IP address. Only VLAN that has an IP address, that is this network here. So that has an IP address. But what about the DHCP then? We press a little more on enter here. Here we see it. DHCP address. There we see it on the inside. DHCPD enable inside. That's the only thing. There is no entry for the gateway, but that seems to be already okay. I think it can just recognize that from somewhere else, because you can put an IP address for the gateway as well. But what we do here, conf and then we DHCPD DNS, and then we write the DNS server address. It was 1.1.1.2, 255.255.255.252. What is that? Yeah, we have to also, no, we don't have to have a subnet mask. DHCP DNS. We just write it like this: interface inside. Yeah, that is the correct thing. I just checked that with by typing half the word and then tab. If it takes the command, then we are in the right place. So here you might think that this is a bit strange that this that you have written inside here, although this address 1.1.1.2 is on the outside. But this inside or outside here is just to tell us which network is this DHCP server working for, and it's working for the inside. So that's why we should do it like that. So that should be configured. We have a look now. Does it work? Click there. You go to static, DHCPD back. Yeah, now it works. You have to do the same thing on the other PC as well, of course. Otherwise, it will not work like this. Okay, that is configured. So now, outside server working. These two PCs is working. Now we go into the middle and have a look at the ASA to configure that one. Well, the first thing that we should do, of course, is to give an IP address to this interface here. It is the ET0/0. We do that. And because this switch, this is a switch really, the ASA is a switch with firewall functionality. So that's because of this, you cannot assign an IP address directly to a switch port because switchboards cannot have IP address. It's just like it is with switches that if you want to give an IP address to a switch, you cannot do it. You have to assign the IP address to the VLAN that the port belongs to. It's just the same here. So we have a look then. What are we going to do? Yes, we were going to assign the AIP address to VLAN 2. So that's why we enter VLAN 2, and then we write IP address 1.1.1.1 and subnet mask 252. Enter, no shut. Because the Cisco ASA firewall works with security levels, we have to assign a security level to this VLAN 2 where the public is. Because that belongs to the internet, it should be security level 0. Security level 0. And name if should be outside. So that's what we've done then. Then we had these, the ports, switch ports where we have added the PCs. They should be VLAN 1 then, so we have to go into that interface as well. Interface VLAN 1, IP, no, IP address we already have. We have to write security level 0 because it's the inside. Security level and then name if also inside. No shut, of course. So now we have assigned the security levels. So now it is time for doing the network address translation. And that's what we do here on the AS area as well. So Network address translation in Cisco systems, or not in all Cisco systems, but in the ASA firewall, is configured within the context of a network object. So we have to create an object first and then do the settings inside that object. So let's see what happened. Object network, and the object that we will create then, that is an object for the inside subnet, because it is the inside subnet. That's what we want to translate, because the outside already have contact with the outside, because it is outside. But the inside needs to go to the outside. So we connect. We do that. Object network 192.168.1.1. And this one here, I will want to explain that for you. What does the one mean? Well, no, I mean the zero, sorry, the zero. What does the zero mean? Well, it means that this is a network. This is not an IP address belonging to any device at all, but it is the network that all the devices belong to. So, object created. So what is the next thing? Now we are inside the object. Yeah, we should define the network subnet 192.168.1 no dot 1.1. That is the subnet that we want to translate. Okay, yeah, I forgot the IP address, of course. Let us see now. Yeah, now it took it. So now we have configured the object. And what do we want to do in this object? Well, not. And from inside to outside. And then we have to configure this as dynamic NAT, dynamic network address translation. Dynamic network address translation means that we translate addresses from the inside to the outside. We write dynamic, keyword dynamic, interface, dynamic interface. Yeah, that's just it. There's nothing more. The interface there, that means that translate it to whatever IP address is there on the outside interface. You don't need to write outside. It understands that it is the outside interface that you're talking about. That took care of the network address translation part. So we can just exit this. Should be working now. So actually, what we have configured now is, all the configurations that will allow the PC to go through the ASA to the server in the internet. But even though you come all the way to this server, which you wanted to do, but the problem is that if that server gets your request and it sends nothing back, then you will not know if the traffic has come through or not. You will have no way of knowing that. So what we have to do now is to let the traffic come in through the ASA and back to the PC. And that can be done through something called stateful inspection. And stateful inspection is like a memory of some kind. It means that you enable a connection memory on the firewall. So that's what you do here. You enable the connection memory of the firewall, and then when you have done so, the ASA will remember all the connections that started from the inside. If this PC went out to the internet to some server, well, when the traffic comes back, it's aha, this is traffic just I saw just a while ago that I'm going to let through. So that one is done. Yes, so no, that one is not done at all. It is now we have to do that. I'm so sorry. So let's have a look at it then. How do we do it? Yeah, we use something called uh, stateful inspection, and we see where that goes then. Conf t first to go here. We must use first a class map. Just press there. Class map. Inspection default. That is a class map that exists on the machine already. Class map inspection default. And then there is some default configuration that you can load it into this default inspection, and that's what we do by writing match default inspection traffic. So this on a real ASA server router, firewall, should make this working, but it really doesn't on the packet tracer. We have to do a few more steps. Match default inspection traffic. Then we have to go to policy map. I have to go out here first, I think. Exit. Policy map, yes. Policy map, global policy. And a global policy is a policy that is valid for the whole system. So here we go. Then now we are inside the global policy. Then we have to see what was the class that we were using, because it's going to use that class. Class inspection default. Yeah. No, it's not really like that. I have to I've chosen the class. Let's see what we have done now. Class map inspection default. Then we have match default inspection traffic. We go outside. Okay, policy map, global policy. See what we should do then. Default. Misspelling. Class inspection default. That is the class that we are going to use. Okay, now we got it right. So here we should write what kind of inspection do you want to have? What do you want to inspect? Inspect. Let's see now then. Inspect DNS, inspect HTTP, inspect HTTPS. Oh, it didn't take that. So obviously Packet Tracer doesn't support HTTPS in that way. Okay, so then we have the next thing. It was DNS. Yeah, inspect ICMP. Yeah, you took that. So now we have HTTP, we have DNS, we have inspect DNS, inspect HTTP, and we have inspect ICMP. Yeah, those were really important. Exit. It seems that I'm running out of electricity here. I have to go and get a cable here. Let's see if we can do it. See if I have to move everything. Okay, we'll do that. Fixed. Yes. The thing I have to do now then is to enable the service policy as well. Service policy, global policy. And so now I'm enabling this policy, but I also have to specify an interface where, which interface would I like to apply this policy to. If I want to apply it to all interfaces on the machine, then I just write a global. Or if I want to just to have to run it on the inside, I write inside. But here I take it on all interfaces. Global. So it seems like everything should be working now. Hopefully we haven't forgotten anything. We will notice that in a little while. So we see this. Have we done this? Yes, we have done this. So where we could start then is of course by pinging the outside router interface. Ping 1.1.1.1. That one doesn't reply. Let's see if we ping the server then. Still, it doesn't reply. No, here it comes. Here it comes. And then we can ping the DNS names that we have. Hooligan. Yeah, that's great. On www then. Also works. But it would be interesting to see. It's not possible to ping the outside interface of the ASA then. No, that doesn't seem to work. But since we can go all the way through the router to the 1.1.1.2, then yeah, it must be that this echo is not allowed to this machine then. Yeah, what else then? Yes, we have, of course, to check it. Does it work in the web browser? That was the important thing. That's what our users want to see. Yeah, it works. Great. Yeah, both of these work as well. So then it's just the other machine. Let's see, do we have, yeah, we have the IP configuration there already. I just go to the web browser right away to see if it works. I'm sure it works now. Yeah. And then with the W. Also works. Okay, that's great then, gentlemen. Everything seems to work just fine. Thank you.